Good evening, sir. This business analytics project is based on the data superstore datasets and focuses on applying supervised and unsupervised learning technique to extract meaningful insights from retail data. The aim of this project is to understand which factors influence business outcomes such as sales impact or the profitability, and to identify the hidden patterns within numerical variables value through the machine learning model only. Python libraries such as NumPy, SkyPy, skitlearn, Matplot that were used here to process the data and doing all the modelings and interpretation. And now my friend Shreyansh will do the data overview.
Hello, my name is Shreyansh and today I will be talking about data overview. The dataset contains 9,994 observations and 21 variables related to customer orders, product categories, discounts, quantities, and profits. The data quality is strong with no missing values and no duplicate records. The sales average value per transaction is approximately rupees 229.85, while the maximum sales value is rupees 22,638, indicating the presence of high value orders. Profit values range from a loss of rupees 6,599 to a maximum profit of rupees 8,339, showing that higher sales do not always guarantee profitability. Discounts range from 0% to 80%, highlighting the importance of promotional strategies in this dataset. Overall, the dataset includes both low-value routine purchases and extreme transactions, making it suitable for analysis. Now, supervised learning will be continued by Rishikesh.
Thank you, Shreyansh. Now I will be speaking upon the supervised learning section. In logistic regression, we use logistic regression because the target variable was defined and the model predicts whether the transaction is affected or not. In the sense that if there is a hike in a sale, how the other factors reflects in which is a binary outcome. The independent variable includes quantity, discount, product category, subcategory, customer segment, region, and shipping modes. The model was trained using around 9,994 records. The result shows was a pseudo R-square value, which is 0.769, meaning that the around 77% of the variation in the outcome is explained by the model. The model's p-value is 0.000, confirming the statistical significance. The analysis shows that the discount is the strongest influencing factor, which is very high, positive coefficient of approximately 29, and the other factors are relatively low when compared to this. From the business perspective, the results suggest that focusing on discount or a high value product and avoiding excessive discount on low value product. Thank you. Now further it will be continued by Anshika.
This is Anshika Chaudhary, and my enrollment number is 0158. So I would be discussing about the unsupervised learnings part, in which we had done the factor analysis and the principal component analysis that were applied to identify the underlying patterns among the numericals variables such as profit, discount, row ID, and quantity, without a target variable, of course, using the Bartlett's test of sphericity, which was significant and it indicated the strong intervariable correlations, while the KMO value was marginally acceptable for factor analysis. We have also used the value max rotation. Two different dominant factors emerged. Factor 1 is driven by discount, and the another factor is driven by the profit. So the discounted variable represented the discount-based sales behavior, while the factor 2 was profit, which represented the profitability. Quantity and row ID showed a negligible loadings, indicating limited influence on these latent factors. This was my part. Now Manav would be continuing with the conclusion part.
Hello sir, my name is Manav and my enrollment number is 0677. So the part that I did in my BA project is conclusion. So in conclusion, supervised learning helped identify the major factors affecting transaction outcomes, particularly discounts and product categories. Then unsupervised learning revealed that discounts and profits operate as independent underlying dimensions, while quantity also alone does not define business success. At last, this project demonstrates how machine learning techniques can support data-driven decision making in retail analytics. Thank you.